Key constraints are actually uniqueness constraints in the sense they say that, or they make sure that no two tuples are going to have the same values in all the attributes, right? So already we know that a relation is by definition a set. Therefore, no two values or no two tuples in a relation are supposed to have the same values. That we already know it, right? Now, how do we make sure, or how do we ensure it is? See, what I mean to say is, let us say this is a tuple, this is a relation, okay, and relation is having various attributes, okay, and now let us say there is a t1 and there is t2. Now, by the definition of relation itself, it says that relation is a set. Therefore, no two values or no two tuples in the relation are supposed to have the same values in all the attributes, right? Which means t1 should not be equal to t2 for any of these values, right? So no two rows should be completely equal, right? Therefore, in order to ensure this, what we do is, sometimes what happens is, we cannot say that even though I am saying that no two tuples cannot have the same values, it doesn't mean that all the attributes have to be completely different. For example, two people may have the same grade. Let us say one of the attribute is the student table, right, and one of the attribute is marks. Now, by this definition, you should not understand that no two tuples are supposed to have the same values in all the attributes. It is not that what I mean. What I mean to say is, some of the attributes can be same, can have the same values, but then all the attributes put together should not have the same values. What I mean is, see, some person might have 10 marks and other person might have got 10 marks, or 100 marks and 100 marks, isn't it? Now, this is allowed, but then having all the values in all the attributes, it is not allowed. That is what I mean to say, right? So, in particular, we are interested in some set of attributes which have to be definitely different for these tuples. So I'll take an example and explain you. So what I mean to say here is, let us say I'll take these attributes. One is student number, and other is student name, and other is marks. I'll take these three attributes from this table. Let us say there are 5 or 6 attributes there. I'll take these three attributes, and now I say that no two students are supposed to have same values in these three fields, in these three attributes, which means no two students should have the same student number, same student name, and same student marks. Let us say it is one student number is 1 and the name is Ravi and the marks is 100. Now I should not have the same values for some other student, as student number is 1, name is Ravi, and then 100, right? So I don't want this to happen. Now such a subset of attributes are called as super key. Okay, so the name is super key. Super key. So super key is actually a subset of attributes. Attributes means the column names, right? The subset of attributes for which no two tuples are going to have same values in all the attributes. Got it? So what I mean to say is, no two tuples should have the same values in all these three attributes. Then this set of attributes is called as super key. Got it? Now you can also think of it in a other way. In other way, what we can think is, these three attributes can uniquely identify a tuple, right? Which means if you specify these three attributes only, we could go into the table and we could locate one particular tuple, and exactly one tuple without any confusion. That is called as uniquely identifying. Therefore, if you have a super key, then you will be able to locate a tuple uniquely given the values of the attributes in the super key. Got it? So it turns out that sometimes even we don't need many of the attributes which are present in the super key. Even after deleting some of the attributes from the super key, we still will be able to identify a tuple uniquely. In this example, you need not have the student name or student marks as a key. You can even have the student name itself to identify a unique, a tuple uniquely in the table. in such a case this is called as a key, right? So what is a key is any minimal super key is a key. Any minimal super key is a key, right? So what do I mean by minimal super key is from the super key, if you delete every extra attribute possible which is not required in order to identify a tuple uniquely, then whatever resulting you get is called as a key. And don't think that key should always be consisting of only one attribute. That is not what I mean. So anything from the super key, if you delete some of the attributes, whatever result you get, that is actually going to be the minimal super key. So key is nothing but minimal super key. Okay, so key is minimal super key. Understanding this? Now just you might think that key should always contain only one attribute. No, let me think of an example for that. Let us say there is something called as door number and street number. Door number and street number. Okay, and let us say there are person name and then maybe age, right? And this is the door number and this is the database of all the people, right? In this case, name cannot be a super key because many people might have the same name, and age cannot be a super key because many people might have the same age, and name plus age might not be a super key because two people might have the same age and then they might have the same name also, right? So it is not possible. Then maybe if you assume that the door number and the street number, right, if you take these two, that might be a super key. Let us say in a door number in a particular house, in a particular in a particular street, let us say only one person is residing, or in a particular door number and in a particular street number only one person with particular some name is going to be present. Then in this case you can think of name, door number and street number. These three fields might be a super key for this, and in this case even if you remove the name, or if you remove door number, or if you remove this street number, you might not be able to find out a tuple uniquely. So in this case this is a key because it is the minimal super key, right? And one thing I want to tell you is about this particular super key. One interesting point is every tuple, since it is going to be unique in a relation, so every relation by default is always going to have one super key. Can you guess what it is? The set of all attributes of the relation are going to form a super key, right? So set of all attributes, always by default every relation is going to have at least one super key, and that super key is nothing but set of all attributes, right? So in worst case, if you are not able to minimize the super key itself is going to be the key, right? So when can you call a super key as a key? If you require all the attributes in order to uniquely identify any tuple in the relation, then a super key becomes the key. In case if you can remove some of the attributes, right, like in this case, let us say you are able to remove this student name and marks, then you can say that student name is the key and then everything is going to be the super key, right? In this case, what can be the super key? Everything. This entire thing can be a super key, and after removing some of them, like age, maybe you are able to get the key, right? Then what is the true relationship between key and a super key? So you can think of it this way. See this? I can write it as if any superset of a key is a super key. Think about it. So what I mean to say is, if you have taken that student name, student number is the key, then you can add any attribute to this key and you can make that combination as the super key. For example, if you know that just student number in itself is enough to identify a tuple uniquely in a table, then to the student number you can add student name and you can declare this combination as a super key, isn't it? Why? Because when student number itself is able to uniquely identify a tuple, then definitely student number combined with student name will be able to identify a tuple uniquely, even though it is not required. That is why it is called a super key, right? Super key might contain some redundancy, and keys might not contain any redundancy. If student number itself is a this key, then you might add student number comma marks. It doesn't make sense, but still it can be used as a super key, isn't it? Or you can say student number, student name as well as marks, everything put together is a super key. Got it? So that is the relationship between key and a super key. See, take all the attributes of the relation, it is going to be the super key. Why is that so? Because we already had the restriction on the relation that no two tuples should have same values in all the attributes. Therefore, take all the attributes, that is going to be a super key, and you try to minimize the super key, then you are going to get a key. Got it? And you take a key and you try to add any attributes, you are again going to get a super key. Then how many super keys are possible given a key? That depends on how many supersets can you form from that key. Are you getting this? For example, if I have let us say attribute a1 as the key, okay, think about it carefully. Attribute a1 is the key, right? And the total number of attributes in the relation is a1, a2, a3, a4, right? Then how many super keys are possible? The number of super keys possible will be the number of supersets containing a1, right? Then how many number of supersets will be containing a1? Already include a1 into that super key. Along with that, you may include it or not, or you may include it or not, you may include it or not. 2 into 2 into 2. Therefore 8 super keys are possible. Got it? So for a given relation, there will be at least one super key and there will be at least one key in worst case. What is these two going to be? The set of all attributes themselves. The set of all attributes are going to be the super key, and in worst case that super key itself is going to be the key if it cannot be minimized further, right? And now the next question is, how many keys can be present for a given relation? So it turns out that there can be more than one key present for a relation, right? Then how is it possible? Just watch it. Let us take an example of a car, okay, or a mobile phone also you can take it. In mobile phone also you are going to have two numbers, right? IMEI number, and the other one is SIM number, isn't it? If you take a mobile phone, then there will be a owner name, right, and there will be a SIM number, and there will be IMEI number, right? And we know that every mobile phone is going to come with an IMEI number and it is going to be unique, and every mobile phone will have a SIM number in case if you have put that SIM on that SIM number, in the sense the phone number, right, the mobile number, which is going to be unique, right? Therefore, using the SIM number, the phone number, you can uniquely identify the mobile, or using the IMEI number also you can uniquely identify a mobile. Therefore, how many key attributes are there? More than one key attribute is there. So what is it? Either SIM number is a key attribute, as well as this IN is also, this IMEI number is also going to be a key attribute. Then what about super key? You take any key and you try to build a superset, then it is going to be a super key. Many super keys are possible there. So sometimes we are going to have more than one key for a relation, right? One more example is, let us say we have a car, okay, car. Then what will be there on the car? One is, let us say owner name, right, and maybe color, and maybe price. So along with these attributes, there may be registration number and engine number, right? Now registration number is going to be unique for a car. Therefore, registration number is going to act as a key in order to identify, because it can identify any tuple uniquely. Therefore, registration number can be a key. and you take any superset of registration number and you include any of the attributes along with that, it is going to be a key, right? That key is super key, right? Not the normal key. And now even engine number is also able to uniquely identify a car, because every car is going to get a unique engine number, right? So there are two keys. So some tables, some relations might get two keys. In that case, what we call that keys is candidate keys. Candidate keys. So what is candidate keys is, if we have more than one key for a table, what is a key? Minimal super key, right? If we have more than one minimal super key for a table, then they are going to be candidate keys, right? Then how many candidate keys are possible? Many. Then we are going to choose one of the candidate key as the main key for the table, which is going to be used later on, or which is going to be used in the physical part. Okay, we shall see it later, but then we are going to choose one among the candidate keys as the important key, and that is why that particular key is generally called as primary key. Primary key, right? So what is a primary key is, one of them is going to be chosen and it is going to play an important role while we insert some numbers, or while we store the table in the hard disk or in the memory, right? So there are various terms here we discussed. I'll just summarize them. First thing we have seen is a super key. Any set of attributes for which no two tuples are going to have same values is called a super key. In worst case, all the attributes put together of a relation is going to be a super key, because of the restriction that no two tuples have to be same. And you try to minimize the super key, you are going to get a key, right? And sometimes, and one more thing, when I say minimize and when I say minimal, it does not necessarily mean that the attribute is going to be one. Even a key might contain more than one attribute, right? So key need not contain only one attribute. Key might contain more than one attribute, like in this case, door number and serial number, street number, right? So you might not be able to use only one particular attribute to identify it. You might need more than one number, right? One attribute. Therefore, a minimal, not minimum, right? Minimal super key. Minimal means, you are going to delete the attributes from the super key until no more can be deleted, right? That is minimal. So any minimal super key, not the minimum super key. What is the difference between minimal and minimum? Minimum means you should count it in terms of the attributes, and you are going to say that it is the minimum. It is the minimum key. That is not what I mean. Let us say, I'll just give an example. Okay, so this is going to be a bit difficult to understand, but try it. Let us assume that we have A1, A2, A3, A4, 4 attributes in a table, right? And now all these attributes put together, they can be called as a super key, right? And now, how is this true? Because it is from the definition of the this relation itself, that no two tuples are going to have same values for all the attributes. Therefore, all these put together is going to be super key. Okay. Now, let us say I deleted A1, right, and then I got A2, A3, A4, right? This entire, only these 3 attributes are able to uniquely identify a tuple. Then what should I call it? Should I call it super key or key? Think about it. Definitely I can call it as a super key, because it still has the property that it is able to uniquely identify a particular tuple. Every tuple is uniquely identified by this uniquely. Now, should I call it a key? That depends. That depends on whether it is minimal or not. Minimal means, can I still remove any of the attributes from this, right? And can I still get a super key, or can I still get that uniqueness constraint, right? Now, let us say it turns out that even we can remove A2 and A3 and A4 turns out to be a combination which is uniquely able to identify a key, a tuple. Then should I call this combination a super key or key? definitely you should call it as a super key. You can call it as a super key because it is still holding the property that no two tuples are having same values for these two attributes, right? Now, should I really call it a key? That actually depends. What? Can you still minimize it? Is it minimal or can you still remove it? Let us say it turns out that if I remove A3 or A4, that uniqueness constraint is not holding anymore, which means if I remove A3, then A4 is not able to uniquely identify a tuple. Then I cannot remove A3, right? And same thing is happening with A4 also. If I remove A4, A3 is not able to uniquely identify a tuple, right? Which means two tuples are having same value for A3 and two tuples are having same value for A4. Then I cannot remove any of this, and still I can, I cannot get the uniqueness constraint. Then in that case, then only you should call it a key, isn't it? Therefore, since it is a super key which is minimal, it is called as a key. Got it? It need not necessarily mean that it is having the least number of attributes possible, right? Now let's take the same one, the same table, the same attributes, and let's see this: A1, A2, A3, A4, right? Then let us say this entire thing you can call it as a super key, that is for sure. Let us say even after removing A2, you got A1, A3 and A4, and these three attributes are having uniqueness constraint, which means no two tuples in the table are having the same values in A1, A3 and A4, right? Then what can you say about this combination? This combination can also be called as a super key. Now, can you call it as a key? That depends. That depends on what? Whether you can minimize it or not. Let us say after removing A1, A3 and A4 are not able to uniquely identify a tuple, which means A3 and A4 are going to have for two tuples same values, right? And the same thing is happening with A3 and A4, which means I am not able to reduce this further. I am not able to delete any one of them, and I am not able to say, oh, it is actually a contradiction, right? The reason is already A3 and A4 is supposed to let us change it. Okay, instead of removing A2, let us say I have removed A3, then what is the resulting? A1, A2 and A4. Now let's see this. Now this A1, A2, A4 is a key, therefore it is called a super key. Now should I call it as a key or not? That is what I am talking about, right? Now it turns out, let us say it turned out that I am not able to delete A1, and I am not because A2 and A4 are not able to uniquely identify a key, and I am not able to delete A2 or A4. Then what should I call it? Since I am not able to further minimize it, then it is called as minimal super key. Got it? Minimal super key, and therefore it can be called as a key. Got it? So A3, A4 is a key, and A1, A2, A4 is a key, right? Then what can we say about it? See this, and let us say there is one more key, A1, A2, A3, A4. Okay, let's stop it here. If I have to form one more, it is not possible. Any single attribute, if any single attribute is so, is not possible. Okay, fine. So let us say this is what we got. The entire thing can be taken as, so we got two keys. One key is A3, A4, a combination of these two attributes, and the other key is A1, A2, A4, right? So without depending on or without taking into consideration the number of attributes, both are called minimal super keys only. So it doesn't mean that this is minimum, so it is, both are actually minimal super keys only. So you should not say that since it is having less number of attributes, it is the key and is not the key. Both are keys, right? And now these two keys are generally called as candidate keys. When do we call it as a candidate key? If you have more than one key, generally the name both will be referred to as candidate keys. So we generally find the candidate keys first, and out of them I am going to choose one of them as the primary key. and there is no restriction. As a database schema designer, you can either choose this one as the primary key or this one as the primary key. In general, it is better if you go with the candidate key, which is having less number of attributes, as the primary key. It is just a convention, not a rule, which means both of them are equally qualified to become the primary key for the relation, and you can use both of them, but then it is generally suggested that you go with the one which is having less number of attributes. It is not a rule. Okay, so let us say this one A3 A4 is taken as primary key. Then these two are going to play a significant role in the further processing of the table. Later we shall see what is the importance of a primary key. So here you understood few things. One is super key, and the other is key, and the other is candidate key, and other is primary key. Got it? These are the points which you should be careful about. So from the candidate keys, we are going to choose a primary key. Super key is set of all attributes is a super key, or any set of attributes is called a super key if it is going to uniquely identify a tuple, and a minimal super key is a key. Got it? And any superset of a key is a super key. If there are more than one minimal keys, generally they will be called as candidate keys. So there is no term generally called as a candidate key. We call it as candidate keys. So whenever we have more than the plural, so whenever we have more than one key, we call all of them together as the candidate keys, because they are candidates to eligible to be primary keys. That is why they are called as candidate keys, right? And from the candidate keys, we are going to pick one of them, and it is going to be a primary key. Got it? Then how many keys are there? Given a key, how many super keys are there? That you can find out depending on how many supersets you can form containing the key. Got it? Let us say, given this key, how many super keys will be there? Let us forget that this is also a key. They are saying that A3 and A4 are A1, A2, A3, A4 are attributes, and A3 and A4 are A3 and A4 is a combination which is a key. Then how many super keys are possible? Then you have to include A3 and A4, therefore only one chance for this, and you can either include this or you include this, or you need not include this or you need not include this. Then two chances, therefore how many super keys are possible? 4 super keys are possible, right? And maybe if you take this one also into consideration, then you have to again think, you have to eliminate some of the combinations, and you have to think about it. Got it? Understood this? So what I mean to say is, before you go ahead and design this schema, you are supposed to come up with the primary keys, and once you identify the primary key, then we are going to underline it. Generally in the schema, relation schema, we are going to underline some of the attributes which are called as primary keys. For example, in employee database, maybe employee number can be a primary key. Then we are going to underline this. Let us say in this car, let us say this what is this? Oh, this is a phone, right? So let us say this SIM number is going to be taken as the primary key, then we underline it. Or if you want to use this one as primary key, you underline this, right? In case if you have more than one attribute as the primary key, then you have to underline both of them. Let us say a door number, street number, and name. These three have to be underlined. So every table should have at least one attribute as the primary key, right? And the next thing is, we don't want any null values to be given in the primary key. Let us say we have considered here A2 and A4, A3 and A4 is the primary key. Then we don't want any tuple to have null values in both of them, right? In case if there is only one attribute which is a primary key, we don't want any attribute to have null value in that attribute, because what happens is, if we allow even null values, then more than one tuple might take the null value, and it becomes difficult for us to identify the tuple exactly given the null value. Therefore, we generally don't allow null values in the primary keys. In case if the primary key is containing more than one attribute, then it depends. Normally we might allow one of them to be null, but not both of them at the same time, right? Or generally, the best practice is, don't make any primary key attribute as null. We stick to that. Okay, we are not going to make any primary key attribute as null. We stick to that. Okay, and sometimes even though an attribute is not a primary key attribute, we still want we still don't want any null values in that attribute. So example is, let us say student name. If you are having a student table, right, let us say there is a attribute called as student name. A student name can never be null, which means there should not exist any student who is not having a name, isn't it? Therefore, some attributes, even though they are not primary key attributes, we make sure that these attributes will never get any null value. That is called as not null constraint. So not null constraint is also a part of key constraints. Understood this? We are done with domain constraints, which says that always the table should not contain multi-valued attributes and composite attributes. Sometimes that is also called as first normal form. We shall see it in the normal forms later. Okay. And next thing is, we are looking at the key constraints, which also talk about the uniqueness constraints, right? And next thing is, we are also saying that some of the attributes are constrained in such a way that they'll never take null values. Example is name of an employee or name of a student can never be null. Got it? So these are the constraints about the key constraints. Okay.